For over 7 decades, our understanding of the solar system seemed complete. A well-ordered collection of 9 celestial bodies, each orbiting our sun. Yet, deep within the frigid expanse, billions of kilometers beyond the most distant known planet, an unseen presence lingered. A faint speck of light, almost imperceptibly, traversed forgotten astronomical photographs. It remained unnoticed and unidentified for years. Its eventual discovery would not merely add a 10th name to our solar system's planetary roster. Instead, it would ignite a profound identity crisis for the solar system itself. Astronomers would find themselves embroiled in a fierce disagreement over the very definition of a fundamental word. This conflict would ultimately reshape our cosmic map forever. This is the narrative of a world that, true to its designation, introduced profound discord into the scientific community. How did a single discovery challenge decades of established knowledge? What truths lie concealed in the farthest reaches of our solar system? Join us as we venture to the turbulent outer boundaries of our solar system. We will encounter Eris, the world that sparked a fundamental debate over the meaning of planet. The saga of Eris did not commence with a fortunate glimpse through a telescope. It began with an ambitious undertaking to catalog the sun's most remote celestial subjects. At the Palomar Observatory in California, a team of astronomers, including Mike Brown, Chad Trujillo, and David Rabinowitz, initiated a systematic survey. Their focus was the outer reaches of our solar system, specifically searching for objects orbiting beyond Neptune. These were designated trans-Neptunian objects, or TNOs. The team employed the 1.22-meter Samuel Oschin telescope to capture wide-field images of the sky. These images were then processed by automated software designed to flag objects exhibiting specific movement patterns. Their efforts had already yielded significant results, with the discovery of new worlds such as Quaoar, Orcus, and Sedna. These findings gradually populated this dark, distant domain. However, the team harbored aspirations of finding something even larger. As Mike Brown later articulated, he believed a 10th planet must exist. The notion that Pluto was a singular planetary anomaly at the solar system's edge struck him as illogical. He decided to manually re-examine older datasets that his automated software had overlooked. After months of meticulous review, on January 5, 2005, Brown began scrutinizing a sequence of 3 images from October 21, 2003. There, within the images, was a solitary, faint point of light. It was moving at an incredibly slow pace against the backdrop of fixed stars. Brown immediately recognized its profound significance. The object was bright, indicating it was either large or highly reflective. Its exceptionally slow movement suggested an immense distance. His initial thought was, "I found a planet." The team commenced tracking the object, provisionally named 2003 UB33. Their goal was to determine its orbit and size. They had intended to keep their discovery confidential until further observations were complete. However, the competitive nature of planetary science intervened. On July 27, 2005, a different team controversially announced the discovery of another large TNO, Haumea. This announcement came after they accessed Brown's team's public observation logs. To prevent being preempted again, Brown's team was compelled to make their findings public. On July 29th, they announced the discovery of not one, but 2 significant bodies in the outer solar system, Haumea and this new object, which would eventually be known as Eris. The secret was out, and the solar system would never be perceived in the same way. In Greek mythology, Eris embodies the goddess of strife. a malevolent deity. When excluded from a wedding, she cast a golden apple inscribed "For the fairest among the goddesses." This act instigated a quarrel that directly led to the Trojan War. In 2005, the discovery of the celestial body that would bear her name became the modern equivalent of that golden apple. It was cast into the very halls of astronomy. This event ignited a scientific conflict over the fundamental definition of a planet. The core issue was both simple and profound. Initial estimations suggested Eris was larger than Pluto. Subsequent calculations, based on its moon's orbit, revealed it was 27% more massive. If Pluto qualified as a planet, then Eris, its more massive counterpart, certainly had to be one as well. And if Eris was to be classified as a planet, what about the other large TNOs recently discovered, such as Makemake and Sedna? Where would the boundary be drawn? The discovery created an unavoidable logical dilemma. As Mike Brown articulated, they would either need to add new planets or remove one. The International Astronomical Union, the global authority responsible for astronomical nomenclature, was compelled to take action. At its 26th General Assembly in Prague in August 2006, the question of what is a planet was subjected to formal debate and a vote for the first time in history. The debate was intense, exposing a deep division within the astronomical community. It split into two primary factions. On one side were those who advocated for a geophysical definition. They argued that a planet should be defined by its inherent physical characteristics. If an object possesses sufficient mass for its own gravity to overcome its material strength, pulling it into a nearly spherical shape, a state known as hydrostatic equilibrium, then it should be designated a planet. Under this straightforward definition, Pluto, Eris, the dwarf planet Ceres, and potentially dozens of other bodies would have been classified as planets. On the opposing side were those who favored a dynamical definition. They contended that a planet's identity is linked not only to its physical state, but also to its gravitational influence on its surroundings. A true planet, they asserted, must be the dominant gravitational entity within its orbital zone. The voting process itself was fraught with contention. The decisive vote occurred on the final day of the 10-day conference. By this time, most of the 2,500 attendees had already departed. Only 424 astronomers were present to cast their ballots, a mere fraction of the global astronomical community. When the votes were tallied, the dynamical definition had prevailed. The IAU passed Resolution 5A, establishing a three-part definition for a planet within our solar system. It stipulated that a planet must A. be in orbit around the Sun, B. be in hydrostatic equilibrium, and C. have cleared its neighborhood. Pluto, sharing its orbital space with Neptune and numerous other Kuiper Belt objects, failed to meet the third criterion. A new category was established, the dwarf planet. This classification applied to objects that satisfied the first two criteria, but not the third. Crucially, a subsequent resolution that would have made dwarf planets a subcategory of planets was defeated. Instead, the IAU declared that planets and dwarf planets constitute two distinct classes of objects. In an instant, the solar system was officially reduced to just 8 planets. Critics immediately highlighted flaws in this definition. The phrase, "clear the neighborhood," was ambiguous. Furthermore, the first criterion, in orbit around the Sun, applied exclusively to our solar system. It disregarded the thousands of exoplanets now known to exist. It was not a universal, elegant principle, but rather a reactive, controversial, and localized solution. With the debate officially settled, the Discovery team had the privilege of naming their disruptive world. They chose Eris, a name Mike Brown felt perfectly suited the object that had plunged astronomy into such profound discord. The name was formally accepted in September 2006. In the years since the 2006 vote, Mike Brown has been colloquially dubbed the Pluto Killer. However, this moniker overlooks the true legacy of his discovery. Finding Eris did not kill Pluto. Instead, it revealed Pluto's true cosmic family. It made our solar system larger, more intricate, and ultimately more fascinating. For decades, we operated with a flawed model. 8 planets of a certain character, and then one peculiar outlier. By compelling this reclassification, Eris provided us with a more accurate and coherent depiction of our cosmic home. There are 4 inner, rocky terrestrial planets. There are 4 gas and ice giants. And beyond them lies a vast third realm, a swarm of thousands of icy dwarf planets. This is a population of worlds whose existence we are only just beginning to comprehend. Eris and Pluto stand as kings of this third zone. They are the largest and most prominent members of the trans-Neptunian population discovered thus far, and Eris itself remains the ultimate enigma. It is the most massive known object in our solar system that has not yet been visited by a spacecraft. While NASA's New Horizons mission provided us with a breathtaking, intimate portrait of Pluto, Eris remains a distant point of light. Its secrets are held across billions of kilometers of empty space. A proposed flyby mission would require an estimated 25 years just to reach its destination. For the foreseeable future, the goddess of discord will guard her secrets. Her discovery resolved one great debate, but it simultaneously opened a new chapter in our exploration of the solar system. It serves as a powerful reminder that the most exciting discoveries are not those that provide final answers. Rather, they are those that reveal just how much more there is left to explore.